We're going to do some more examples of hypothesis testing for two independent samples. Okay, so let's say we have this question. How many full-page ads are found in a magazine? In an October issue of Muscle and Fitness, there were 252 ads, of which 97 were full-page. For the same month, the magazine Glamour had 342 ads, of which 167 were full-page. Is the difference significant at an alpha of 0.01? So notice the wording, is the difference significant? It's not saying Muscle and Fitness is greater than Glamour or Glamour is greater than Muscle and Fitness. We just want to know if there's a difference. So here's an example where your claim or your alternate hypothesis is going to have the not equal to sign. Okay, we're trying to claim that they're different and that that difference is statistically significant at a level of significance of 0.01. Okay, notice also there's some indications that it's a proportions problem, like if this were on an exam and you needed to figure out if it was a mean problem or a proportion problem. You've got 97 out of 252, and you've got 167 out of 342. So you can kind of tell it's a proportion problem. Okay. Notice it's a two-tail problem, or a not equal to in the claim. You're just wanting to see if there's a difference or not. So your hypotheses are going to look like this. Okay, again, go to two independent proportions. Group 1 is the 97 out of 252. Group 2, or Glamour, is 167 out of 342. And you're just wanting a not equal to here. Just trying to figure out if there's a difference between Group 1, Muscle and Fitness, and Group 2, Glamour. Again, the hypothesized difference, always 0. And 99% confidence because you had the level of significance of 1%. Okay, when I hit OK, I've got the results here. Notice they show my proportions, so about 38% versus 49%. P-value is 0.0122, and here's the test statistic, or the z-score. But p-value is going to help me determine my conclusion. 0.0122 is not less than 0.01, so p-value is not less than alpha. So we cannot reject the null, and there's no support for there being a difference. Okay, notice if we can't reject the null, then we're going with the null, and the null always has the equal sign. So we're not showing any difference here. No evidence for the difference. Okay, not enough evidence for a difference in proportion of full-page ads. Okay, p-value is not less than 0.01, so we can't reject the null, and there's no evidence of a difference. But notice the conclusion would change if our level of significance, or alpha, was 0.05, because our p-value was 0.0122, and that is less than 0.05. So if we change the confidence level to 95%, which means alpha, or level of significance, becomes 5%, we can reject the null, and then we do have evidence to show a difference. Okay, so notice it's sometimes important what confidence level you choose. Since both 95 and 99 are pretty common, you might want to go with 95% in this case because it's still high and it's still common. If we're trying to show that there's a difference in the proportion of ads, then there's nothing to say don't go with 95%. Unless your manager or boss or coworker says you got to do 99%, then yeah, you're just not going to find a significant difference. It's all about comparing the p-value to the level of significance. Okay, let's look at another example. This is kind of an interesting one. In one of the more unlikely collaborations of modern medicine, Britain's largest children's hospital has revamped its patient handoff techniques by copying the choreographed pit stops of Italy's Formula One Ferrari racing team. The hospital project has been in place for 2 years and has already helped reduce the number of mishaps. That's from an article in the Wall Street Journal. So suppose a hospital in the U.S. has adopted these new techniques. They've studied their surgical handoffs both before and after using the pit stop techniques. So notice the terminology before and after. That's an indication that this is a two-sample hypothesis test problem, not a one-sample Chapter 9 problem. From a sample of 53 handoffs prior to the changes, they found that there were 20 handoffs with technical errors. So basically 20 out of 53 technical errors. From a sample of 65 handoffs after the changes, they found there were 18 handoffs with technical errors. Okay, so notice the terminology kind of helps me determine that this is a proportion problem because I've got 20 out of 53, I've got 18 out of 65. I also see here that I have two samples, one from before the 53 and one from after the 65. So that's another indication that this is a two sample independent samples hypothesis testing problem. And notice the final question. Has the proportion of handoffs with technical errors decreased since the changes? Even though that says decreased, I'm putting the before first and then the after. So the before should actually have more errors than the after. So it's a greater than problem when you consider the order. Remember, the mouth of the sign is always on the bigger number, the point of the sign is always on the smaller number. So if I'm wanting to show that the technical errors have decreased, then the after should have the smaller number. Okay, since we want to know if the number of errors went down, the after should be smaller than the before. So it would look like this. Your claim is that the before is greater than the after. The null hypothesis always has the equal sign. Okay, when I run this with the data, with those proportions, the p-value is 0.167, which is not less than our common values of alpha, like 0.01, 0.05, and 0.10. So we can't reject the null. So in this case, we have to go with the null. And that means we did not find evidence for the after being smaller than the before being greater than the after. Okay, we did not find support for this, so we have to go with the null.